In this video, we will talk about the variation of sample mean and the distribution of sample mean. Knowing the variation and its rule is important to help us correctly evaluate the estimation and validate assertions about population based on the samples. For example, you have historic data of 100 days. You can compute sample mean and variance of stock return. Based on the statistics, can we draw inference to the parameters? How close are the statistics to population parameters? By observing the stock data of 100 days, can we make a claim that this stock is in an upward trend, that is, mean of return is positive? All this rely on our understanding of sample mean distribution. Here, we take a sample with sample size equal to 30 from a population with normal distribution, mean equal to 10 and standard deviation equal to 5. If you run this cell several times, you may get different result from there. For example, like this, like this. It is because the samples are randomly drawn from the normal distribution. Different samples will yield different means and standard deviation. This is called the variation of sample. Furthermore, the sample mean and standard deviation do not change arbitrarily. It also follows some rules because they are all taken from the same population. To see that, in this code, we generate 1,000 samples from the same population. We record mean and variance for each sample and save in a data frame collection. Mean list is the name of a list to save sample means of 1,000 samples. VR list is the name of a list to save sample variances of 1,000 samples. Then we will generate 1,000 samples in a loop. For each sample, we compute the mean and variance and save them into mean list and VR list. Finally, we build an empty data frame called a collection. We save mean list and VR list in different columns of this data frame. We can draw histogram for the collection of sample means. It looks symmetric and like a normal distribution. The histogram of sample variance is not normal. As you can see, it is right skewed. We can guess, in fact, we can mathematically prove that the sample mean has a normal distribution. If population is normal with a mean equal to mu and variance equal to sigma squared, then the sample mean is also normal with a mean equal to mu and variance equal to sigma squared divided by sample size n. Why variance of a sample mean is smaller than variance of a population? Intuitionally, the sample mean is the average of n individuals of population, and hence the variation of sample mean is smaller than the variation of individuals in population. Here is a demonstration using Python. The blue histogram is for population. The red one is for the sample mean. What if the population is not normal? Central limit theory of statistics says if sample size is large, the distribution of sample means looks like normal one. Hence, we can conclude this way. Even if the population is not normal, the sample is approximately normal if the sample size is large enough. Here's an example about distribution of sample mean when the population is not normal. As you can see here, APOP is a data frame name which saves the population. In this population, we only have 5 values, 10, 10, 1. We can generate 100,000 samples with small sample size 10. you can see that in this histogram, for sample means, it does not look like a normal distribution. But if you generate 100,000 samples with large sample size 2,000, the distribution of sample mean now looks like a normal distribution. In this video, we mainly talk about distribution of sample mean. We describe probability rule of variation of sample mean. We will apply this in next two videos to explore two important quantitative statistical tools, confidence interval and hypothesis testing.